Geometry students, welcome to our first video lesson for our new unit. We are officially in Unit 6, and Unit 6 is all about right triangles. And what we'll see is we're going to see radicals, which is a super fancy word for square roots, as well as cube roots, and so on. But we're going to see those come up in our problems where we're dealing with right triangles. So this is like a little algebra review of how we simplify square roots to make sure that we're feeling good before we apply them to problems. This is the first video. In video 2, you're going to be looking at the Pythagorean theorem. Okay, so you'll watch this one and then that one next. So some vocab that you're going to hear in the video. We're going to evaluate or simplify square roots, right? Radicals is a fancy umbrella term. If you hear the word radical, get my pen, there we go. Radical applies to things like square roots, things like cube roots. The fourth root of a number, it applies to any root. Remember the idea of like a square root is just saying like what number times itself equals 25, right? Whereas a cube root would be like what number times itself 3 times is equal to 8. So the kind of index number of 3 or 4 tells you how many times you would have to take that particular number times itself to get to whatever's underneath the radical. So that's kind of the difference between them. So we're going to focus mainly on square roots, but just a heads up that it includes other concepts under the term radicals. And we're going to talk about like what an exact answer is in terms of radicals versus giving a decimal approximation. So those are some words that you're going to see kind of come up just as a heads up. So this is the first radical, or specifically square root, that we're going to simplify. I'm going to pause the video and pull up my calculator. And it's always a good idea to double check if it comes out cleanly before we look at other methods. So in this calculator, notice the square root is yellow, so I have to hit my second yellow button before clicking this key and then type 169. If you've got a scientific calculator, like one of the smaller ones, this is a graphing calculator, yours probably has a similar way to get the square root button as well. So notice this one comes out cleanly as 13. So the idea is what number times itself is equal to 169, right? That's the same idea of what a square root is, just in different words, and it turns out to be 13. Okay, so just practicing square roots. And then this one is the square root of 80, and we're asked to estimate it. So let's think through what square numbers we know, because that one doesn't look like it's going to be super clean. Like I know 1 squared, 2 squared. Sometimes I find making a list of all of the perfect squares helps. In fact, on your homework assignment, the first question asks you to make a list of all of the perfect squares that are under 50, because those are kind of the most common that you're going to see. 8 squared, 9 squared. In fact, like, you know, going up to 60 or 80 is also good rather than just under 50. These are probably, you know, most common. Same thing with like 10 being 100. So if I'm looking at these, I'm trying to find the square root of 80, right? All of these answers tell me like that the square root of 100 is 10, right? That's the number times itself. So if my answer is supposed to be 80, it's bigger than the 64, but smaller than 81. So that tells me it's like between 8 and 9, right? We can kind of infer that it's something between 8 and 9, right? Because 8 times itself, right, is 64, or if you want to think about it as the square root of 64 would be 8. The square root of 81 is equal to 9. That might be a better way to think through it. I could kind of infer that it's closer to a 9 than to an 8. So I might say it's like maybe like 8.9, right? Like it's pretty close to a 9 compared to an 8. that we can estimate about what it should be. If I wanted to check, I'm going to get my square root of 80. Looks like it is 8.944, so we were pretty close with our guess. The next thing we're going to do is simplify the same thing, the square root of 80, but this time we're going to look for an exact answer. So an exact answer is going to be a little different, right? It's not going to be a decimal approximation, right? I'll write down the decimal approximation that we just found was about 8.94. Right? But that's rounding. It's not the full exact answer. The exact answer, if I go back to the top of the page, is going to be in simplified radical form. Okay? So my exact answer, I need to keep it in terms of square roots. Exact answer is going to be in simplified radical form. Basically, it's just fancy words for just saying we want to leave square roots. So the question is, how can we break down a square root? It's actually a really interesting idea. So here's what I'm going to show you guys, and I want you to notice some things. So what I've done on my calculator is I've done the square root of 80 as a decimal, right, the 8.94 that we saw. I also did the square root of 40 times the square root of 2 and multiplied those together, and their decimal approximation, the product is about 8.944 as well. I did the square root of 8 times the square root of 10, and that's also 8.944. So you might be noticing a pattern with these at how the 40, the 2, and the 8 and the 10 pairs correspond to the 80. So you probably have guessed that we can break it up by multiplication. So a general rule would be something like that. The square root of a times b, it's kind of like the square root of 80, I could write as 4 times 20 maybe. I can break it up as the square root of 4 times the square root of 20, if that makes sense. So this is how we can break up the square root of 80. Now the question is, which pair is the best, right? There's a lot of pairs that multiply to be 80. And it's kind of tricky. The trick is we want to pick the biggest perfect square that fits into 80. So we're seeing that 80 is divisible by 2 and 8, right? 40 and 10. And we want to try and 4 and 20, right? I don't think I did the 4 and 20 in the calculator. But we want to pick the biggest perfect square possible. So that's the goal, is we want to find a product, right? Two numbers, or you could think about them as like a pair, right? Product pair with the biggest perfect square. Something that we can square root. So let's look at what that could look like. I'm going to take 80, and this is why it's handy to have that list of perfect squares that we had up here. I'm going to take 80 and I'm going to divide it by perfect squares just to make sure I get the biggest one. So 4 goes into it, right? The next biggest one is 9. That's not going to fit. I'm wondering, what about 16? Could that one fit? And 16 actually fits, and 5 and 16 seem like a good pair. So what I'm going to do is I'm going to rewrite this, and I'm going to rewrite the square root of 80 as the square root of 16 times the square root of 5. Now the reason we want to pick a big perfect square is because this can be simplified further. The square root of 16, what number times itself is 16? That's going to be a 4. And then the square root of 5, we can't do anything with that, so we're going to leave it as 4 times the square root of 5. Notice, if I take this, let's double check square root of 80, right? Square root of 16 times, just to verify everything, square root of 5 I meant, right? Those are all matching. What about 4 times the square root of 5? Notice you don't have to write the multiplication symbol there. And it does check out, right? I'm verifying with my decimals just to be safe. Now, you might be asking, well, what if I didn't pick the biggest perfect square? What if maybe I picked a 4 instead, and I did 4 and 20? A lot of students will kind of jump to a 4 with this one, right? Because 80, it's a lot easier to see a 4 fitting in than a 16. So I could say the square root of 4 is 2, and then 2 times the square root of 20. And then it has an extra step compared to the original one, because you would have to then break down the square root of 20 into a square root of 4 times the square root of 5. So this is going to turn into 2 times root 4 times root 5. The square root of 4 is a perfect square. That's why I picked it. So it's going to be 2 times 2, right? The square root of 4 is 2 times the square root of 5. Notice that's going to simplify. The 2 times 2 is going to give us that 4 square root of 5, just like we had before. So either way, you'll get to the same answer. If you pick a smaller perfect square, not the biggest one, you're going to have a little bit more work along the way. Okay, this one's kind of tricky. So make your list, or take your list of perfect squares and test some of them out to see which one fits. So you can kind of see my division here. I started dividing by 16. 384 divided by 16 was a 24. And I said, oh, that kind of seems a little bit big. And I was like, oh, let's keep going. So I did that 16. I did 36. I got 49. Eventually I did 64. And it ended up coming out cleanly. The reason I kept going was because 16 times 24 is a pair that works. But 24... seemed like too big of a number, right? I know 4 goes into 24, so it seemed like that one could be broken down further. So I just kept going until I got to a bigger even number that fit cleanly, if that makes sense for a strategy that might help you through that kind of a problem. And the square root of 64 is 8. Okay, let's try another one. So try this one, go through your perfect squares and see what's the biggest that fits into 405. So I've got my perfect squares listed on the side. It turned out to be 81 times 5. That was the biggest perfect square. This one is pretty tricky. You just kind of have to try them and plug them in, right? To simplify your final answer, I'll show you guys what that looks like. You're going to keep the 8 in front. It's just going to kind of hang out like a coefficient. And the square root of 81, we know 9 times 9 is 81. And then notice that the 8 times 9 do multiply to give you that 72, just to kind of see that through. And then the square root of 5, it's kind of tacked onto the 72. It's kind of like 72x, right? It's like a coefficient almost. And you want to keep those separate. You don't want to like mix things. So square roots go with square roots, and numbers hang out. The final one that I want to show you guys is what happens if I square a square root of 17. It's kind of weird to think about, right? Like kind of do it like this. If I kind of put them back together, we've been breaking them apart, but if I put them back together, 17 and 17 make 289. The square root of 289 is 17. There's kind of an interesting pattern there if you notice, right? Right, the square root of 17 squared gives you back the 17. There's something about squaring a square root that you're undoing, right? It's kind of like adding then subtracting, multiplying then dividing. Those operations undo each other, which is really quite interesting. For this one's a little harder. So it might help to think about this one as 4 root 5 times 4 root 5, and then kind of separate them into two problems, the 4 and the 4, and the root 5 and the root 5. I know that this is going to give me a 16. This is going to be times the square root of 25. And kind of keeping track of that pattern, you kind of get that 5 back at the end. So it's going to turn into 16 times 5. And 16 times 5, real quick check, is 80. So these are pretty interesting. We'll do some more practice like this in class on Wednesday. Okay, go ahead to video 2 where you're going to review the Pythagorean theorem.